Section B. Sine, cosine, and tangent curves.
Now we need to learn how to graph the trig functions we've gotten to know so closely. Make sure you got a good grasp of graphing trig functions.
Collision derby!
We'll be doing our graphing using radians. However, you can always switch to degrees. Remember, radians and degrees are just different ways of measuring angles.
When graphing the trig functions, t is traditionally used for the independent variable, and y for the dependent variable.
In other words, y depends on the value of t for its own value. Its self-esteem is kind of low. For example, y equals 2t. You don't know what y is unless you first know what t is. Y is dependent on t for its value. We showed you how to measure angles in degrees and radians. Now we're going to pull a little switcheroo. Instead of using theta, alpha, gamma, or beta to name angles, we will use t. We will also be calling the x-axis the t-axis because we're going to be measuring this t angle in radians instead of degrees. These radian measurements will be shown on the t-axis, which used to be the x-axis. We're first going to give you a brief overview of the steps you take to graph a trig function.
The first step is to choose some radian or degree amounts. Second, you want to find the trig function values for these radian or degree amounts. In these first two steps, you're setting up a table of values, which you'll plot your graph with. Your radian or degree amounts are your t values, and the trig function values for your radian measurements are your y values. Your last step is to plot these points on a coordinate graph and connect them with a smooth curve.
Don't worry, we'll go through each of these steps. The first trig function we'll graph is a sine curve. We'll start with the graph of y equals the sine of t. So the first thing we need to do is to set up a table of values. Remember, we're just choosing some radian values, then finding the sine value. We're just using radian values for our table to keep things simple. You can also use degrees if you want to.
Let's choose values from 0 to pi radians. For the most part, it doesn't matter which values you select to graph trig functions, but we'll talk more about that in a second. These radian values we've chosen will be our t values on the coordinate graph. Remember, the x-axis is now the t-axis. To graph the sine curve, we're going to find the sine amount for each of these radian values. The sine value for each of these amounts will be our y value. These t and y values will go on a coordinate graph. Let's take a look at our table of values.
Here's our selected values starting at 0 and ending at pi radians. There are, of course, values between these measurements, but we don't need all the values to graph a curve. Notice that the table shows t in radians and degrees. Our second step is find the y values. To do this, we plug the t values into our y equals the sine of t equation. So we just punch in the radian value, then hit the sine key. After using our calculator, we find these values for y.
Once you've set up a table of values, then you plot the corresponding points by finding the radian value on the t-axis and the trig function value on the y-axis. The radian values increase as we move to the right on the t-axis. Our last step in graphing trig functions is to connect these points with a smooth curve.
Now we'll plot these points and connect them with the help of our friend Sluggo, the graphing snail.
He's Sluggo, the graphing snail. He graphs without any bait. He's pretty good. Yeah.
Back to our graph.
Don't forget, the t-axis has radian values now. It's now time to plot each point on the graph. We'll just graph a few points here until you get the idea. 0 radians on the t-axis is here. The sine of 0 is 0. So we stick our first point here. Now we'll plot pi over 2 radians. It's here on the t-axis. The sine of pi over 2 radians is 1, which is here on the y-axis. So we'll plot the point here. To plot pi radians, we find pi radians on the t-axis. The sine of pi radians is 0. So this is our point on the t-axis. Here's the rest of the points on the graph if we plotted them all. Let's follow Sluggo as he connects the points.
We'll continue this process where t is an angle from pi radians to 2 pi radians. We'll again use some selected values.
Here's our table of selected values. Again, there are amounts between these values, but we don't need them to graph a sine curve. After we've selected our values, our next step is to find the sine value for each radian measurement. So you punch in these amounts and hit the sine key. We get these y values. Notice that these sine values are negative. That's because the angles between pi radians and 2 pi radians are in quadrants 3 and 4. Remember, as angle t moves into quadrants 3 and 4, the y values are negative.
Why? Well, remember earlier we showed you that when angle t moves into quadrants 3 and 4, the sign of the angle is negative. Well, that's what it's doing from pi to 2 pi radians.
So look here, my graphing friends. We're back at our coordinate graph with the part of the sine curve we already graphed. Don't forget, radian values increase as we move down the t-axis. Now we'll again plot a few points. 3 pi over 2 radians is here on the t-axis. The sine value of 3 pi over 2 radians is -1. -1 is here on the y-axis. So we'll plot a point right here. The next value we'll plot is 2 pi radians, which is here on the t-axis. The sine value of 2 pi radians is 0. That means we'll plot another point here. After plotting the rest of the points and following Sluggo around, we get this smooth curve on our graph. This is the basic graph of y equals the sine of t from 0 to 2 pi radians. You have now graphed a sine curve.